Hello everyone, welcome back to my channel. In this video, I'll be solving one linked list problem from Leetcode. So before jumping to the problem description, let me tell you that this video is going to be a part of our competitive programming playlist. The idea of this competitive programming series is to learn how to approach a coding problem. So here, what we are going to do next is we are going to go through the problem description. We'll try to understand the problem and then we'll see how we can code the solution in a very naive approach, and then we'll see how we can optimize the solution. Okay. So here, if you see, the problem is middle of the linked list from Leetcode. So let's go through the problem description. Here it is saying, given a non-empty singly linked list with head node, head, return a middle node of linked list. If there are two middle nodes, return the second middle node. So let's understand this from the examples. So in example 1, we have given a linked list with 5 nodes, 1, 2, 3, 4, 5. So here the node 3 from this list is the middle node, right? As we can see, this is the linked list with odd number of nodes. So 3 will be the middle node for this linked list. In example 2, if you see, we have a linked list with 1, 2, 3, 4, 5, 6, where we have even number of nodes. Now, as in the problem, it mentioned that we need to return the second middle node. That means for in this example, we have two middle nodes, right? One is 3 and other one is 4. But in this case, the problem says we need to return the second middle node, which is 4 here. That is the reason node 4 from the list will be the middle node for this example. So let's try to see how we can approach this problem. So for that, I'll go to my presentation. So here, for example, let's say we are given this linked list, right? Where we have 1, 2, 3, 4, 5 as the node, and we also have the access to the head node. The naive approach to this problem would be to simply iterate through this linked list and get the count of the node. So for example, in this case, the node count is 5. Then we can simply divide this node count by 2. Here we will get 2, and then by adding 1 to it, we will simply get the middle node, right? So once we have this position known which needs to be returned, what we can do is we can iterate through the linked list again to return the node at position 3. So for example, we need to iterate to position 3 and then we can simply return this node, right? So this would be your solution, the naive solution, right? Similarly, when we have even number of nodes in a given linked list, we can simply follow the same steps. We'll iterate through the linked list, we'll get the count of nodes. For this example, we have the count of node as 6, and then we'll simply divide it by 2, we'll get 3. And then as in the description, it has asked for the second middle node, we'll simply need to add 1 so that we can get the position of the node which needs to be returned. And then again, we iterate through the linked list up to that position, and then we will be returning the middle element. So here, if you see in this approach, if we try to calculate the time complexity, first thing we are doing is we are iterating over this linked list till the end, right? That means to iterate over this linked list, the time complexity would be order of n, as we have n number of nodes, right? And then again, once we have that count, we again need to iterate up to n by 2, right? So as soon as you get the position from where you need to return the middle node, you have to traverse it again, and this will be n by 2. That means again you have to traverse up to n by 2, right? Then only you will be able to return the middle element. That means the overall time complexity would be order of n plus order of n by 2. And the space complexity would be order of 1 because we are not using any extra space. So if you notice, whenever you will get such problems in your interview and you come up with this solution, the interviewer will definitely ask you to optimize this solution. So now we can think how we can optimize this. So to optimize this solution, what we can do is we can use a method called tortoise method or a two-pointer method. Now I'll explain you what this method is and how it works. So for example, let's say you're given this linked list, right, with 5 nodes. Now what you can do, you can simply use 2 pointers. One would be your slow pointer and other one would be your fast pointer. And both of them will be pointing to your first node. Now, whenever we move a slow pointer by 1 position, the fast pointer will move by 2 positions. So let's say if I move this slow pointer by 1 position, then the fast pointer will move to the node 3. So it will look something like this. Here, now the slow pointer is pointing to the node with value 2 and the fast pointer is pointing to the node with value 3. Now from here, the slow pointer will go to the node with value 3, and as this is a fast pointer, this will move to the node with the value 5. So at this point, what you can simply check is if your fast pointer is at the last node, then you can simply return the slow pointer. And if you notice, your slow pointer is pointing to the middle node, right? So let's say if you are given this linked list with an even number of nodes, then how it will work? So let's iterate this. So slow pointer will move to 2 and fast pointer will move to 3, and then again slow pointer will move to 3, fast pointer will move to 5, and then slow pointer will move to 4, and the fast pointer will move to null, right? So it will definitely cross the last node. So whenever you have a linked list with even number of nodes, your fast pointer will reach the value null, right? So as soon as you see that the fast pointer is pointing to null, that means you are good to return the slow pointer, which will be pointing to the middle node of the linked list, right? So as in the problem, it is mentioned that you need to return the second middle element. That's why this solution works, right? So let's say if the question has a different requirement, let's say if the question says you need to return the first middle element. So in that case, you can simply store the previous node and you can return that as well, right? And also what you can do is you can also stop at this point where you will be checking if this is the second last node. If your fast pointer is pointing to the second last node, you will be able to return the first middle element. So now we know how we can get the middle element. For this solution, now we can talk about the time complexity. So here, if you see what we did, we simply used 2 pointers and then we keep iterating it, right? So if you notice, this fast pointer moves 2 positions, right, at once. That means at most it will take n by 2 to reach to the end of the linked list. That means the time complexity of this solution would be order of n by 2 and the space complexity would be order of 1. So now is the time we'll see the code for this solution. So for that, I'll go to the Leetcode editor, and here I'll simply write the code for that. So here if you see, they have mentioned the structure of your node, and then in this method you need to write your solution. So here you have access to the head node, right? So the first thing we'll do, we'll simply create a slow and the fast pointer. So for that, I'll create a list node. I'll call it slow, and this will be pointing to your head node. And similarly, we will have a fast node which will also be pointing to the head node, right? And then what we simply need to iterate through this linked list, right? So here the condition I'll put in the while loop would be that either it should be a last node or it should be a null, right? As I mentioned, that if you have a linked list with odd number of nodes, then the fast pointer will reach to the last node. Otherwise, it will point to a null for the even count of the linked list. So here what we can simply check is if your fast node is not equal to null and fast.next is not equal to null. So here, as I mentioned, the slow pointer would move only one step. So this will be slow.next, and fast will move 2 steps. So this will be fast.next. Okay. And at the end, once your iteration is done, you can simply return your slow pointer. As we know that slow would be pointing to the middle element, right? So that's the code for this. Let's run it and see. So if I click on run code, so here if you see, it passes the test case. Now I'll simply submit it. So here we'll be able to see the code. So here if you see, the solution has been accepted. So yeah, that's the solution for this problem. That's all about this video. If you learned something from this video, please hit the like button. And if you're new to this channel, please don't forget to hit the subscribe button and press that bell icon so that you get notified for our upcoming new videos. Thank you for watching.